Now that we have discussed about a chord of a circle, now comes the most important concept used in circles connected with chords. Diameter is what we're going to discuss in today's session. Diameter of a circle. So what is a diameter? Now that we have discussed about a chord being defined as a line segment which joins any 2 points on the circle, similarly a diameter has its own definition. So let's see how a diameter is defined and how we connect the chord with the diameter. To start with, the definition of the diameter. So in order that I define a diameter for a circle, let me take a circle into consideration. So here is the circle out here. Now this circle has the center. As we know that every circle is derived from the fixed point which is the center. So this circle also has the center. Say my center out here is this dot. Now let me just take the definition before I understand the diameter. So here comes the definition of the diameter. A diameter of a circle is the line segment which passes through the center of the circle. Now here we have many line segments which pass through the circle, but there's only one fixed line which passes through the center. So here any line which passes through the center is called diameter. Suppose I have a line AB which passes through the center, then I call this line AB as diameter. AB is the diameter. So in this diagram, since AB passes through the center of the circle, since AB passes through the center of the circle, therefore AB is the diameter. Is how we conclude the diameter of the circle. So in this diagram, this is the diameter. Diameter of a circle is AB, and its definition is given out here. So we finally conclude that a diameter of a circle is the line segment which passes through the center of the circle. So here this is the diameter because this passes through the center. If I take a line AB which does not pass through the center, then this line is not a diameter, but this line is a diameter because it passes through the center of the circle. Is how we understand diameter of a circle connected with a circle. Now that we have defined a diameter connected with the circle, now comes the concept of how we connect a diameter with the chord. How do we understand diameter through the chord definition as we have taken in the previous session? So this session is about connecting diameter with the chord of the circle. Diameter versus chord. So in order that we understand diameter in terms of the chord, let's revisit the chord definition. So chord is defined, a chord is defined as the line segment which joins any 2 points of the circle. Is how we understood the chord. That is, when I take this in terms of understanding through the diagram, I have this to be a chord Suppose I take the points A and B. This is a chord. Is how we understand. The line joining any 2 points of the circle is a chord. Then what is diameter and how is it connected to the chord is clearly understood through this definition, because when we say diameter, diameter is a line which passes through center of circle. So if I connect any 2 points in such a manner that it passes through center, then I can say that a line segment or a chord which passes through the center is the diameter, because a chord is nothing but defined even for a diameter. So if I take the line segment P and Q passing through the center, then clearly I can say that PQ is a special chord for the circle and PQ is given by the name diameter, because any line which passes through the center of the circle is a diameter, and hence the special chord PQ passing through the center must be the diameter for the circle. So here I understand that AB is the chord but cannot be the diameter, because this line AB does not pass through center, but the line PQ is the diameter, because it passes through the center. Simply, since it passes through center is how we understand the chord connected with diameter, or a diameter connected with the chord. And importantly, we have to understand that if I take the length of this chord and the length of this chord, we clearly understand that the diameter, which is also a chord, will be the maximum length. So length of the diameter will be maximum. It is the highest chord in the circle. Also is one way I can connect with. So here I make the learning outcome that diameter, which is nothing but a chord, is the longest chord in the circle. So AB, PQ are the chords in which PQ is the longest chord because it is a diameter passing through the center. So my learning outcome here is that diameter is the longest chord in the circle, is how we understand the relation between a diameter and a chord. Diameter derived from a chord passing through center of circle. Now that we have related chord and the diameter for the circle, where diameter is nothing but a chord derived with a special case of passing through center. Now comes the discussion of how many possible diameters we can draw for the circle. Today's session is about the possible number of diameters which can exist in a circle, investigating the number of diameters in a circle. Possible number of diameters in a circle. So let's see with a circle taken into consideration and investigate on the possible number of diameters in the circle. I have a circle . Now let's say the center of this circle is here. Now as we know that diameter is a chord passing through center of circle, therefore let's take the different possible chords which pass through the center from various different directions of the circle. So if I start from this direction, I have a chord A1, B1 with a point A1 out here and a point B1 out here in the circle. Similarly, let me take another chord passing through the center in some other direction. So here I have A2 and B2. So here I have a point A2 which is taken on the circle and the point B2 taken on the circle in such a manner that all these three are collinear. Let me take one more in some other direction. I take here So here I have another line passing through this center. So this is A3 and B3. So here is different set of lines taken into consideration, but interestingly all three lines are passing through the center of the circle. That means all the three lines as drawn here, the dotted lines, are the diameters for the circle by definition of diameter. Therefore, initially I take A1, B1, which is a chord, a special chord, and hence is the diameter. Similarly, I take another line A2, B2 out here. Which is a diameter. And similarly, I have the third one, which is A3, B3. So as I see here, since there are infinitely many points on the circle, I have infinitely many pairs of lines which I can make passing through center. So therefore, for infinitely many points in the circle, I have infinitely many diameters coming into existence. So my learning outcome here is that for any circle I take into consideration, the possible number of diameters in the circle are infinitely many. So therefore, there are infinitely many diameters in the circle. So coming to this, I can just draw the conclusion that since a circle has infinitely many points, since a circle has infinitely many points, therefore there exists infinitely many lines passing through the center of circle. Therefore, I conclude that since there are infinitely many lines which pass through center of circle, therefore a circle has infinitely many diameters. So this is the conclusion we make in case of number of diameters. My learning outcome, a circle has infinitely many diameters, is what we come into investigation of diameters of a circle.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.